Okay, let's dive into the source material you've shared. We've got some really interesting stuff here, really pulling back the curtain on scalable vector graphics, SVG.
Yeah, think of this as your quick guide, really. Getting you up to speed on what SVG actually is, how you can manipulate these graphics, animate them, control how they appear.
And even embed them in some pretty smart way.
Exactly. We're pulling out the key takeaways from this PDF source.
So our mission here is to unpack the essentials, from what SVG is fundamentally, its history, which is kind of surprising,
Definitely.
through how you move things with transforms, understand coordinate systems, animation, and then look at some examples. Real-world stuff that shows the power, but also maybe some unexpected hurdles.
Right. Get ready for maybe a few aha moments about web graphics.
Okay, so first up, what is SVG? The source defines it pretty clearly. It's
Yeah.
a language, uses XML.
Yep, XML to describe 2D graphics. And the core thing, text-based files. That's fundamental.
Unlike, say, a JPEG.
Exactly. No pixels grids here. It's code describing shapes, lines, and the PDF notes you can add animation and changes over time using SmellL.
SmellL, synchronized multimedia integration language.
That's the one. Or, more commonly these days, scripting like JavaScript, you layer that on top of the basic graphic.
What really jumped out at me, though, was the history.
Hmm.
It's been cooking since 1999.
Yeah, quite a while.
Yet the source points out it still has, and I quote, limited support by layout engines. That's surprising.
It is a bit strange, isn't it?
Yeah.
And despite that, there's this push mentioned, positioning it as a Flash replacement.
Feels like a long road for a tech with that kind of history.
It certainly does. And that history, that layout support issue, ties right into something the source highlights early on.
Which is?
Controlling the position, the layout, the flow of SVG content within the SVG file itself. Apparently is quite difficult.
Okay, that's a big one. So if the SVG can't easily place itself on a page, how do you manage that? Where does it go?
Well, the solution offered in the source is basically, don't try to do it inside the SVG. Use your standard web tools.
Like HTML and CSS?
Exactly, HTML, CSS, maybe JavaScript. You position the SVG element itself from the outside, just like you'd position a div or an image.
Ah, okay. So you treat the whole SVG as a block you put somewhere on the page. That makes sense.
Right.
But once it's placed, what about manipulating things inside it? Moving a shape, resizing, spinning it.
Now you're talking about the transform function. That's the key tool here. The source says it applies to specific elements, like groups, G, reusable bits, use, even paths themselves.
And the source breaks down the main types. First, translate.
Yeah, translate just shifts things. Changes the origin point, the X and Y coordinates. So
Yeah.
transform, translate 30 units right, 40 units down. Simple.
You rotate.
Spins it around its origin. Transform, rotate 45, gives it a 45-degree turn. Plus or minus for direction.
And scale.
Changes the size, bigger, smaller. Transform scale to, makes it twice as big. Give it one number, it scales uniformly. Two numbers, you can stretch or squash it on the X and Y axis independently.
The source also mentions skew X and skew Y. Sounds like distorting it.
Yeah, slanting along one axis. And then there's matrix.
Matrix sounds complicated.
You can look it,
Wow.
but it's powerful. It lets you combine all those transformations, translate, scale, rotate, skew into one command. Uses transformation matrices, like in maths.
Oh, the matrix A, B, C, D, E, F thing.
Exactly. You plug numbers into those letters based on the transforms you want. The big benefit, the source notes, is performance, especially if you're doing lots of transforms at once. There's also a phi color matrix for color stuff.
Okay, so transforms handle the dynamic changes within the SVG, but you mentioned SVG lives in this infinite space. How do you control what piece of that you actually see?
Right, that brings us to coordinate systems. The source starts with the viewport layer.
The viewport, like a window.
Exactly like a window. Imagine this huge infinite canvas where your drawing exists. The viewport is the frame, the actual rectangular area on your web page or screen where the SVG will be displayed.
And you need to make sure your drawing is behind that window otherwise.
You won't see it or it'll get cut off. The source stresses aligning it properly.
So viewport is the window frame. What about the viewbox parameter?
Okay, so the viewbox works inside that window. It defines which rectangular area of that infinite canvas you want to map onto the viewport. It tells the browser, take this specific region of my drawing.
And make it fit in the viewport.
Precisely. But it also controls how it fits. Does it stretch? Does it scale uniformly? That's where preserve aspect ratio comes in.
Ah, okay. Preserve aspect ratio is part of viewbox.
Yes, it's a parameter for viewbox. It's absolutely critical, as the source indicates. It governs the scaling and alignment. Do you keep the original shape, meat or slice, or let it distort? None.
And if the shapes, the aspect ratios of the view box and the viewport don't match.
That's where the alignment values come in. X-min, Y-min, X-mid, Y-min, X-max, Y-max, and combinations. It decides which edges or corners to align to if there's empty space or if content needs clipping.
And the meet versus slice thing.
Right. The source explains meet makes sure you can see the entire view box content. It scales down uniformly to fit, potentially leaving empty bars in the viewport.
Like letterboxing a movie.
Exactly. Whereas slice makes sure the entire viewport is covered by the view box content. It scales uniformly but might cut off parts of the graphic if the proportions don't match. It's about prioritizing visibility versus filling the space.
Makes sense. A key decision for responsive design. The source also mentions viewbox 0 turns it off, and no negative width or height, good constraints.
Important details, yeah.
So we've got the display areas sorted, scaling handled, transforms for movement. How do we actually draw this stuff?
The source emphasizes paths.
Paths are really the heart of drawing in SVG. They define everything: lines, shapes, curves, arcs, all the rendered content.
And the source says you can connect them, blend them, create really complex stuff. Absolutely. You can design them visually in vector editors, export the SVG code, and then crucially, you can animate or modify that path data later with scripting.
And the source lists all those commands: M, L, H, V, C, S, Q, T, A, Z, with upper and lowercase versions.
Right. Uppercase for absolute coordinates, lowercase for relative. It's like giving instructions to a pen. Move to here, draw a line to there, draw a curve.
Yep.
You build up complexity from these simple commands. Z closes this shape.
Okay, that's the drawing toolkit. But what if I have a complex shape, like an icon, and I need it 10 times in my graphic? Do I copy-paste all that path code?
No, you don't have to.
Yeah,
That's
okay.
exactly what the def element is for. Definitions.
Like defining a variable.
Sort of, yeah. More like defining a reusable component. The source explains you put your graphic code, a shape, a group, whatever inside defs, give it a unique ID.
Like my icon.
Exactly. And then anywhere else in your SVG, you just use the use element with an xlink.href pointing to that ID. Like use xlink.href #myicon.
So define once, use many times. That must save a lot of code.
Huge savings in file size. It makes updates way easier. Change it in defs, changes everywhere you've used it. Super efficient.
Nice. Okay, let's get things moving. Animation. The source confirms SVG can be animated.
Definitely. And it highlights using smell, as we mentioned, or scripting like JavaScript, which is probably more common now for complex stuff.
And you can animate pretty much anything. Elements, text, paths.
Yeah, elements, text, images, the vector shapes themselves. And
Yeah.
because it's rendered dynamically, the source knows you can trigger animations from events like mouse clicks and chain them together.
So interactive graphics.
Exactly. The basic idea, as the source lays it out, is moving from value to value over a certain duration.
Yeah.
But you can get fancier with specific timings, key points, even motion along curves using splines.
And the specific animation commands mentioned.
Well, there's animate for changing almost any attribute over time: size, position, color. Animate motion is cool. It moves an element along a path you define.
Like make an icon follow a swooping curve.
Precisely. And animate transform lets you animate those transforms we talked about: rotation, scaling. The source gives examples like making something spin continuously.
Using animate transform type rotate and repeat count indefinite. Got it.
Yeah, repeat count indefinite for looping. It opens up a lot of possibilities.
The source also mentions audio briefly. You can add sound.
You can, apparently, via a media player element or tied to the animation timeline. Supported formats depend on the browser, but WAV and MP3 are common.
It lists parameters like audio, the source link, xlink.href, volume, audio level, start time, begin maybe on click,
Yeah.
and repeats, repeat count. Seems less common, but interesting. It's possible.
Adds another potential layer of interaction, yeah.
Okay, so we have these potentially complex, animated, maybe even audible SVGs. How do we actually get them into our web pages? The source introduces this data URI method.
Yes, DURIs, Data Uniform Resource Identifiers. This is a neat trick.
How does it work?
Instead of linking to a separate .svg file, you take the entire content of the SVG file, all that XML code, and you encode it, usually using base64.
Encode the text itself.
Yeah, you turn the code into a long string of characters.
I that.
Then you embed that string directly into your HTML or CSS.
And the source highlights a big benefit here: file security.
Right. Because the graphic isn't a separate file anymore, it's harder for someone to just right-click and save it. The image data is part of the page code itself.
That's clever. Where can you use this encoded data?
The source lists a few places. Directly in an MD tags src attribute, in CSS as a background image using URL,
Well,
or inside an object tag, You just need the right prefix, like data.imagesVG plus XML base 64 before the encoded string.
A very practical tip, especially the security angle.
Definitely adds a layer of protection.
Okay, let's try and tie this together by looking at the examples in the source. First, there's this SVG content viewer.
Yeah, this one's interesting because the SVG is the web page structure. But the key thing the source points out is that the actual content, text, images, whatever, is all external. It's pulled in.
Which avoids that issue the source mentioned earlier, where self-contained SVGs can be easily downloaded with everything inside. This one acts more like a container.
Exactly, like a frame. You see titles, gradients, links, edit tags, animated text. But the really powerful bit shown is foreign object.
Foreign object.
Yeah, it's an SVG tag that lets you embed non-SVG stuff like HTML.
Right.
The example shows embedding an iframe and standard HTML links inside the SVG layout. It's SVG acting as a container for regular web content.
Oh, whoa, okay. That's a serious bridge between SVG and standard HTML. Then there's the animation example. Looks like it uses a lot of what we discussed.
It really does. It shows CSS styling inside style tags within the SVG, grouping with G, animating attributes like size and color with animate, using filters for effects like blur.
Defining gradients and paths in defs for reuse.
Right. And crucially, it shows animating the D attribute of a path inside defs to make the shape itself change over time. Then it uses use to stamp out that animated path, even rotating the instances with transform.
So reusable animated components?
Exactly. And importantly, there's a script section in this example too. It shows JavaScript controlling the animation, starting it, stopping it, changing things dynamically. Really highlights SVG as programmable graphics.
Finally, that complex example, the HTML5 cover graphic, the source compares SVG to JPG here.
Yeah, and this really hammers home the main SVG advantage, scalability. Zoom in on the SVG logo, it stays sharp. Zoom in on the JPG, you see pixels. Vector versus raster.
There's a catch mentioned here, right, about the gradients.
Ah, yes. A really important observation in the source. For this specific, complex graphic, the intricate gradient effects didn't render quite as well in the SVG version shown compared to the JPG. It didn't fully capture the richness.
So while SVG can do gradients, complex ones might be a challenge.
It seems so, or at least it depends heavily on how they're authored and what the rendering engine supports. It's a noted limitation in this case. It shows SVG isn't always a perfect substitute for really complex raster art, especially with nuanced shading and gradients.
Interesting. But even with that gradient issue in this example, the source still points back to the other benefits.
Right. The security, harder to just download the SVG code compared to the JPG.
Right.
And it reiterates that ongoing challenge of layout engine support, potentially hindering wider use for complex layouts.
It leaves you feeling like SVG is this incredibly powerful tool, but maybe one with some specific quirks or areas where it's still evolving or facing practical limits?
That sums it up well, I think. Powerful, but with nuances.
So wrapping this up, we've really dug into SVG based on this source material. It's XML text-based vector graphics.
We saw the power of transforms for moving, scaling, rotating things.
Understood viewports and view boxes for defining the visible area and controlling responsive scaling.
Looked at PABs as the core drawing tool and defs for making reusable components.
Explored animation using SmellL, or more likely, JavaScript, making graphics dynamic and interactive.
And even touched on embedding methods like data URIs for integration and a bit of security.
The examples really brought it home, showing SVG as a potential page structure with foreign object, showcasing complex animations, but also hitting that wall with complex gradient rendering in one instance.
And reminding us about those persistent challenges like direct layout control and consistent engine support.
It's clear SVG has deep roots, massive potential, especially for scalable dynamic graphics, but it's not without its real-world considerations.
Absolutely.
So thinking about everything we've covered, the strengths, the weaknesses highlighted in these sources, the ongoing evolution, how might you now see vector graphics like SVG playing a role in the future of web design or interactivity for your own projects? Something to mull over.